Hello students, welcome to the Yupp Master. Today we are going to discuss the very important topic, light. So in the duration of this class we are going to discuss the many properties of the light in a small interval of the time. So if you are going to have a look in this class, you feel very happy because of all the properties of the light are going to be discussed in a better way with the well crafted animated videos and modern teaching aids. Within the short period of time you will gain more knowledge. Let's have a look please. Yes. Yeah. First of all, we are going to know about refraction of light, even though we are going to discuss that reflection also, and we are going to other properties of the light, total internal reflection also, but have a look. So refraction, first of all, refraction is that one phenomenon which was related to the two mediums, that is denser, rarer. It's very clear. Let's have a look. Yeah. If you are going to take that, you need to guess which one is denser, which one is rarer. Just have a look. Light is incidented. The incidented light has been refracted. So, refraction is the phenomenon of bending of light rays. Very clear. So, if you are taking that bending of light rays, it conveys light has been entered from one medium to another medium. It's very clear. From medium 1 to medium 2, light has been entered. It's very clear. So, it has to move in this direction generally, but it has been bending. Okay, how you will measure that angle with respect to the normal? This is the normal. This is one reference. At the point of contact, the perpendicular distance at the point of contact of the two media is normal. We can take that. It is very useful. So, our topic is how the bending of light rays will take place and what are the phenomena are going to be changed during refraction. So, we have incidented. This is the normal. So, light is allowed from one medium to another medium. Very clear. Light has been entered, but the bending towards the normal. Yeah, the bending is towards the normal. If you are taking that normal, yeah, you can take that this is a normal. So, if you are going to look, no, light ray has been incidented towards the normal. It's going to be. You can guess it, light is allowed from rarer medium to denser medium. It's very clear. Rarer medium. Yeah, if it is going to be allowed, yeah, yes, it moves away from that. It is denser, moving away from the normal towards normal. This is towards normal. It's very clear. Now you can take that this is a rarer medium and denser medium. Okay. All right. It was confirmed that matter. This is the rarer medium and denser medium. how you will decide that refracted light ray bends towards the normal. Yes. So, away from the normal is the case we can discuss. Light enters from water to air. Light enters from glass to air. It's very clear. Now, you can take that. What are the phenomena are going to change during the refraction? Please take that. First of all, velocity, wavelength, energy, and one parameter remains constant, that is frequency nu is constant. It's very clear. Now, if you are taking that, yes, light is the form of wave. It's very clear. Yes. The number of oscillations made by the light incidented. So, the number of oscillations in case of the incidented wave and refracted wave is same. It's very clear. So, here we would like to take that mu and mu dash, but mu is equal to mu dash, very clear. Even though there exists a change in wavelength, lambda changes, very clear. We have discussed that important property. Light has been entered from one medium to another medium. Lambda changes. If you are going to look first one and second one, lambda is also going to be changed. That is, you can confirm the frequency remains same, speed will changes. Very clear. It has been changed the direction. Its speed has been changed, no doubt at all. Speed has changed. It's very clear. Now, while you are going to talk about that energy of the incidented wave is slightly differ from the refracted wave. So, after the refraction, some part of energy is absorbed. Here we can know that this energy E, this is E dash, we will create. It's very clear, right? You know that E is greater than E dash. Now you can have the different relations to go for lambda and lambda dash also. Yeah, very clear. Lambda dash is greater than that of lambda. But by knowing that E is equal to h nu by lambda, E is equal to h E dash is equal to h, yeah, take that, yeah, h nu by lambda dash. So 1 by lambda is greater than 1 by lambda dash. So lambda dash is going to be having that is not equal to lambda. Now from that relation, what can you say about that? Lambda dash is greater than lambda, that is very clear. Yes, we have discussed within the span of short time, we have discussed about all the refraction of the light. It is all about know the refraction of light. Do you know very well about that consequences? Due to the refraction, what happened? The lower, the bottom of that pond, the bottom of swimming pool is going to be raised when you have been viewed at other than 90 degrees. Other than 90 degrees. Simply, if you have been incidented the light ray, you have been incidented the light ray normally, it doesn't get that refraction. So in order to get that refraction, the light ray has to be incidented other than 90 degrees. That is very clear. Now let's go for another one. Please have a look. Yeah, you are going to extend that light is entered from one medium to another medium. Again it is going to enter another medium. Let's see that now. What you are going to see that. Yeah, this is one medium. Yes, light has been entered from first medium to second medium to third, and third to fourth. You can assume that this is the presence of air. This is the air medium. This is the air medium. Yeah, let's see what happened. I think so you have idea about this. What topic that I am going to reveal to you? Relative refractive index. Relative refractive index. Just you have to compare that refractive index. Whenever it enters from one medium to another medium, again it is going to enter from one medium to another medium. Let's see that air. Yeah, that is you have taken. This is the first medium. This is the second medium. This is the third medium. Again it is going to be entered into air medium. No doubt at all. Now if you are going to take that, this is, yeah, you can guess that refractive index also. Yes, 2 as compared to, yes, please look into that matter. This is the refractive index. Please take that refractive index. Value. Yes, that is first one, second one, third one. You should take that. This is also fourth one. Light enters from rarer medium to denser medium. What we have discussed. Again, denser medium to rarer medium. Denser medium to rarer medium. Yes, first of all, it moves. Please look into the matter. In the duration of that time, you need to understand that the refracted ray moves towards the normal, while it is going to be taken as denser. This is the denser medium. This is the, as compared to this one, these two pairs, this is rarer medium. This is rarer. From denser to rarer, it is going to be identified. The refracted ray moves away from the normal. Again, you can take that. This is as compared to these two. This is denser. This is rarer. Very clear. From denser to rarer, moves from the away from the normal. The refracted ray. This is the refracted ray. Refracted ray. You can take that. This is the incident light ray. No doubt at all. Have you seen that? In the short interval of time, you have been gained the knowledge regarding to that special case. When light enters more than two media. First medium, second medium. What happened? You have seen. That is the observation. Very good observation. Please keep it up. Now, you can go for the problems. Very simply, if you are able to solve the problems regarding to two media, that is first one and second one, simply in application part they will put another medium, they will attach another medium, and they will attach another medium. Why you are bothering about these things? If you know the solution, if you know how to solve the problem in case of two, just it is extended. That's what you are going to appearing for the competitive examinations. They are giving the application type of the questions. Nothing is there. The principle is same. Just your thinking abilities are going to be extended. Just you have to apply what you know and you will solve the problem. That's enough. Nothing to worry. Just you can solve the problem. This is, yeah, we are going to take that relative refractive index. Refractive index. That is, you are going to take that. This is mu1, this is mu2, this is going to be mu3. Again, this is mu1. What is relative refractive index? Refractive index of the first medium with respect to the second one. Just you can write down. Therefore, mu21, we are going to take that. Just your refractive index of this medium with respect to the first one. When light enters from one medium to another medium, that is, this is mu relative, that is mu2 by mu1. Example, you can take that glass water. You will take that glass. The refractive index of glass, it's going to be 3 by 2. Water 4 by 3. So you can take the case light enters from water to glass, let us assume. Therefore, refractive index is going to be mu g by refractive index of glass with respect to the water is mu w. That's very clear. Yeah. Just you will take that 9 by 8. It's going to be 1 point. Yeah, you can take, just you will compare. Yeah, this is very clear. It is the, at the same time, if you are going to take that, light enters from glass to water. At the same time, you will find out that refractive index. Yeah, you will find out that it is going to be 1.1. 1.12, let us assume. What is the actual refractive index of the glass? 1.5. It's very clear. So that's what, there exists a relative refractive index value which is less than that of original value. So light enters from denser to rarer. You have calculation relative refractive index. It is very clear. Is it possible to calculate when light enters from water to glass and glass to water to calculate the relative refractive index? That is very clear. That is denser to rarer, rarer to denser. You can calculate the relative refractive index. Just you are going to have the comparison with respect to another one. That gives the relativity, relative. Right, it is very clear. Let's go for another one. Yeah, that is the relative refractive index we have discussed. Right. Now, let's have a look what happened when you are going to take that. Yeah, this is a rectangular glass slab. Suppose we are assuming the upper and lower surfaces are allowing the light rays to pass through them. That is, the refracting surface is on either side. Let you know what happened. See that light is incidented, incidented ray, refracted. Here you will confirm the refraction has been takes place due to the two refractive surfaces, first surface and second surface also. It is having that. There is a possibility to emerge the light. Very simple. The refraction takes place 2 times. Very clear. But actually, the light ray has to move in this direction. Yeah, it is. Light ray has to move in this direction. What happened due to the refraction? Simply, light allows from air medium to glass medium to air medium. So, there exists a variation, a slight change in its path regarding to the direction. So, this perpendicular distance, Yeah, this is the perpendicular distance. What you call? Simply, at all, these are seems to be parallel lines. Incidented light ray and emergent light ray are parallel. Very clear. These are parallel. When? If the glass slab has been placed by the same kind of medium, upper side and lower side in all the sides. Otherwise, they are not parallel. Very clear. It is a special case. Now, our topic is related to, it is known as lateral displacement. Very simple. The distance, the perpendicular distance between the incidented light ray and emergent light ray is known as lateral shift or lateral displacement. Sometimes you may call it as lateral displacement. Yeah, when it is allowed, light has been incidented other than 90 degrees. Just you have to take that existence of lateral displacement. Very clear. You are going to take that angle, yeah, angle of incidence I and angle of refraction. Again, there exists a refraction. This is theta, what we are going to take that. Yeah. Yes, refraction through a rectangular glass slab. In this case, these two lights, we are going to take that parallel. The light rays are parallel. What about that? You can take incidented, emergent. Both are parallel. We have to learn what are the outcomes from this experiment. These are going to be parallel and angle of incidence is equal to angle of emergence. When it is possible, if these two light rays are going to be parallel and the medium, the presence of medium is same. Very clear. Now, from the given topic, what they are going to ask the questions in entrance examinations, all in general. So, you are about to calculate you are about to calculate lateral displacement. Right. How you will d lateral is equal to, it depends on thickness also, thickness of this glass slab. We can take that thickness, angle of incidence. We would like to take that, and if it is going to be identified, that angle of refraction also. Now, that is lateral displacement T into sin I minus R by cos R. This is the formula. They are going to ask that if the angle of incidence is going to be very small, just we can take another type of formula, right? If it is going to be having another one, that is d is going to be taken as T into 1 minus 1 by mu. So, very good. It's case of small I is small, angle of incidence is small, angle of refraction is also small, then you can take that. But what type of application question? You can take that D is summation, that is D summation. They are going to ask that T1 into 1 minus mu 1 plus T2 into 1 minus mu 2, that is the relative refractive index, plus, and you can take that when it has been taken another one. Yes, it has been taken. You have taken different. So, you are going to take that, this is the first one, thickness of the first rectangular, second one. Yeah, you might be having the third one. They might be asking the questions regarding to this one. Very clear. So, this is a one kind of formula, this is one, this is also extended application. It is very clear. Now, let us go for another one. I think so. You are all having that clarity. It is correct. They are parallel until same medium. They are having the same medium. Okay. Yeah, if you want, just you can take that screenshot also. It might be useful. You can recapture that information whenever you need. Right. Let's go for another one. Rectilinear propagation. Yeah, light ray is going to be having that straight line path. It exhibits the path described by a light ray is straight line. Whenever it has uniform, it has medium, it is allowed to pass through a medium of uniform density. It's very clear. Yeah, that is rectilinear propagation. Simply you will get that straight line. Yes, you are going to take that in a one medium. Yeah, it is having that. It allowed to move that. But while you are going to observe that light is a form of wave, yes, you can take that. This is light is emitted. This is the light ray. Light ray. Or while you are going to higher classes, you may name it as light wave or light wave. Simply wave. This is the wave. Yes, it is very clear. So you have taken one light ray. You may take that group of light rays which are confined to a one plane. You can take that. They are going to combine with each other whenever they are having the same amplitude and same frequency. That is another case. You can talk about that interference. In the higher classes you can learn. Nothing to worry. Just you can take that. If you are going to take another light ray, they are going to have that interference. Nothing. You can have that. You can extend it. This is the extended part we have to learn. That is very clear. Now let's go for another one. Yeah. Absorbed. A portion of light is absorbed whenever it has been incidented. Reflection. Very simple. In the lower classes you have been studied about the reflection. Please take that. Yeah. What is the phenomenon of reflection? The bouncing back of the light rays into the same medium. That's called reflection. It's going to be taken as. Yes, you can see that. Yeah, light is incidented. Yes. Yeah, it's going to be incidented. It is normal. For the case of refraction and reflection, normal is one reference parameter to identify the angle of incidence. This one, both are equal. So these two are equal. We can say that I is equal to R according to Snell's law. Incidented light ray and reflected light ray. The bouncing back phenomena of incidented light rays in case of one transparent medium. Just you can take that this is a silver coated mirror, not the transparent medium. So when it is allowed through a mirror, the mirror it has silver coating. So silver is the best metal. Silver is the best reflected. Silver coating. Yeah, best reflector. It's very clear. That's what they are using the silver metal. It's very clear. Now let's go for another one. Yeah, you would like to talk about that incidented light ray, reflected light ray and point of incidence. Right. Now you can go for normal, angle of incidence and all these things measured with respect to the normal. The angle of incidence with respect to the angle made by the incidented light ray with the normal is known as angle of incidence. The angle made by the reflected light ray, while you are discussing about all the phenomena at a one time we are having, it's a reflection. Even though with respect to the refraction we can take that angle of refraction with respect to normal. It's very clear. But the angle of reflection can be measured by normal, reference of normal. Now you can take that laws of reflection, Snell's law, first law and second law. Yes, you can take that. Yeah, incidented ray, reflected ray and the normal all are lie in one plane. Yeah, that is very clear. Angle of incidence is equal to angle of reflection. Now let's go for observation. Yes, you can take that is a one light reflecting surface. What happened? You have been incidented the light rays. It has been reflected. Very clear. And you have taken, this is a normal. This is the normal. Yes. Right? And I is the angle of incidence, R is the angle of reflection. Why? The light ray is confined to the same medium after the reflection, if it has gone through another medium. So that is very clear. Yes, you can take that angle of incidence, angle of reflection and the reflected ray. Yeah, it is going to be, while you are going to talk about that angle of incidence and angle of reflection, both are equal. Yeah, I is equal to R. It's a plane mirror. Now you can take I is equal to R, that is law of reflection, but all these are lying in one plane. This is the Y and X plane. Yeah, within that plane you can understood. This is the incidented light ray, this is the reflected light ray and the normal. Just you can represent the normal with another color, easily you will identify. This is the normal. They are lying in the one plane. Just you might be knowing it is a one plane. They are lying in one plane. Yeah, simply they will confine to a one plane. This is the XY plane. In this way you can easily understood that matter. Light rays are confined to one plane after the reflection. Just you have to take incidented, reflected. Very clear to understand with the help of XY plane. Now easy to understand this. This is I and R. Yeah, I is equal to R. This is the case we have to look. Yeah, by the virtue of this diagram, this picture, you can easily understand that matter. It is very clear. Let's go for another one. Yeah, types of reflections, regular and irregular. Yeah, you can take that. All the reflected rays are parallel. That is regular reflection. How do you decide that? The surface is going to be very smooth, not having the rough and irregular contacts. It is having that smooth surface. Then all the incident light rays, first one, it is parallel. It is parallel. Yes, yes. It is the incidented light rays and the reflected light rays are parallel in case of regular reflection. Yeah, that's very clear. If all the reflected light rays are parallel, that is very clear. Should know that. Now, what about irregular reflection? Let's see. Smooth polished surface. When does it happen? When the light rays allowed to incident on smooth surface, polished, well polished surface. Now let's go for irregular reflection. Let's see. Yeah, this is a irregular, but that surface is not going to be having regular. Some gaps you may be find out that they are having. When you have that microscopic view, you can easily identify this one. What happened? Let's see. The incidented light rays. Yes, yes, yes. The reflection takes place, but after the reflection, what happened? See, the reflected light rays are deviated. They are not in parallel. they are deviated. Even though they are confined to one plane, but they are not parallel. They are limited to one plane. There is, due to this, this is the irregular. Just you can see that this one, this one, this one. You are going to take that irregular contact surface. Contact surface. Very clear. Now we have cleared that. It is also known as diffused reflection. Yes. Let's go for another one. Yeah, transparent plane. It is going to be represented. Yeah, this is a transparent plane. Just reflected side and polished side. This is a going to be polished. Yeah. Just you will take that. Just you can see that what happened. Yeah, light is reflected. You can take that. Here you will know that according to Snell's law, I is equal to R. That is very clear. Actually, the light has to pass in this way. It has to pass in this way. Other than, yeah, it's going to be in this way. Right. But while you are talking about that, it's going to be 180 degrees. Right. You can, while you are going to calculate that the angle of deviation, how it is going to be. Right. It is going to be deviated. What about that? Total 180 degrees. While you are going to calculation, just you can take that. This part, it is going to be calculated. Yeah. Angle of deviation. Can be measured in case of a one plane mirror. That is, the deviated light ray at a angle, it is going to be measured by the help of incidented angle. And sometimes if you know in the problem they have given the angle of reflection, you can easily find out that. That is 180 degrees minus I plus R. But theta deviation, just theta deviation, that is 180 degrees minus I plus I, 180 degrees minus 2I. That is very clear. Yeah, right. Let's go for another one. Total internal reflection. Yeah, it's very clear. We have discussed already in the classes, but you can look into that matter. What happened? Total internal reflection is, instead of refraction, it has observed. Now the incidented light ray has been refracted. It has been refracted, but what happened if you further increases the angle? It is going to be reflected. Instead of refraction, the third one, yes, it is going to be reflected, even though you are going to change that angle of incidence. Very simple phenomena. It is that the phenomenon of reflection of the incidented light rays into the same medium, instead of refraction after particular angle, that is the critical angle. Very clear. Yes, this ray is only refracted. So what is the condition? Light ray enters from denser to rarer. That is very clear. Yes, light ray enters from denser to rarer, and here that, please, here that angle of incidence, that is theta I, it should be greater than theta C. Condition is theta I is going to be greater than theta C, where critical angle. It is very clear. Now let's go for another one. Applications of optical fiber. It's very, yes, let's go for previous one also. You can take, this is the necessary you have to consider the light rays only greater than the critical angle, incidented greater than the critical angle. They are getting the total internal reflection. It is very, very useful. Due to the total internal reflection, the consequences, mirages are formed. There exists a brilliance of diamond, that is a sparking of diamond, and optical fibers are going to be working. Let's see that applications. Here we would like to working of optical fiber, it's very clear. Sparking of diamond, mirage formation. Yeah, mirage formation. What happened in the hot summer? The lower surface is going to be heated, it's going to be exhausted. Yeah, simply due to the different temperatures at the upper surface and lower surface. Upper surface is the air is going to be moved to a upper surface, that is going to be lighter one, and rarer one, lower one. Just we have to think about that variation of the different layers. There exists a mirage formation and looming. A test tube inside the water shines like a mirror. Let us take that optical fiber. Yes, it is a device working on the total internal reflection. Transfers light energy. Simply, it will transfer the light energy, means the light waves are transferred from one end to another end at high speed. Let's see. Yeah. Just you are using that frequently we are using that optical fibers in various places to have the communication, especially they are used in the communication of light signals. Simply the information has been carried with the light waves at high speed. In olden days what happened, we are going to send the information with mechanical waves. It took long time to reach the long distances. Yeah, that it has some limitations. After every 2 kilometers and 3 kilometers, you need to amplify that. That is in the higher classes you can learn. Let's see that how it is going to be. Optical fiber communication is based on that total internal reflection. Let's see that. Yeah. Let us see. Working of optical fiber due to total internal reflection. But the condition, the angle of incidence is going to be greater than theta critical. Just in one expression you can understood the topic. That is very clear. Yes, angle of incidence is going to be greater than that of critical angle. So do you know critical angle is different for the different material. It is not going to be same for all the materials. Even though there exists a fraction of changes in their composition, even though we are taking the glass materials, different kinds of the glasses are there. Yeah, silica carbide and flint glass, quartz glass, Crookes glass, different glasses are there, but all the glasses are not having the same critical angle. Okay, for that you need to incident greater than that of the critical angle. So you are going to prepare that glass material, you have to incident the light rays. Let's see. Yeah, let's see that this is a very interesting topic to know. Really, we are all going to having the realization how it is going to be working. Even though we are using the internet facilities and all, we are having the all luxurious benefits at a high speed communication. Yes, this is the modern way of transferring the signals through the optical fiber. This is the optical fiber, we can see that. This is the glass material. This is having that. Yeah, light enters. Yeah, light enters. Yes, the incidented light ray, this is the, let us assume this is the normal. The incidented light ray, yes, you can take that. It is going to have that total internal reflection. Let us see. Here, theta I is greater than theta C. While you are talking about the glass material, the for the glass material, theta C is about 42 degrees. Very simply, just we are going to talk about that accurate value. Yeah, theta to about 41.85. Yeah, approximately equal. So it was approximated 42 degrees. Now you are, in order to achieve the population inversion, you have to incidentate theta I is greater than 42 degrees. Very clear. In either the direction, because the light is incidented in upper side and lower side, in all the directions that we are going to couple the light. This is a coupling zone, light launching zone into that fiber. So what is the use? With the high speed it will carries the information. With high speed it carries the information. Very clear, but that is a secondary. But our topic is going to be total internal reflection. When does it happen? Please have a look. Yeah, this is the glass material. When you are going to bend the fiber, when you are going to twist that fiber, nothing happened, because it is flexible, it's easy for installation and all. So many advantages are there, but you have to take that speed also. Information has been transferred with the light waves at high speed among the various places in the world. It has been connected to play the vital role in communication. That is very clear. Now you can take that glass metal more than what happened when you have been incidented less than that of angle of incidence. Less than 42 means they are going to be refracted, but there exists a total internal reflection. What you can see that, yeah, either way. Here also, this is the light ray. Yes, you can take. Yeah, this is the incident light ray. Light. Here you will find out that theta I is greater than theta C. That is, while you are talking about that, theta I is greater than 42 degrees. Theta I is greater than 42 degrees. Then only it will happen. Suppose you have taken that diamond, its critical angle is about 24.41 degrees. Yeah, you need to take that 24 degrees is a reference. You have to incident more than that of angle. It's very clear. Light has been incidented. Please see that once again. Light is incidented. It is going to be total internal reflection. Again, it is going to be having total internal reflection. It is incidented. It is very clear. So, with the help of this phenomenon, optical fibers are working. This is the optical fiber. Have that used in communication. Used for communication purpose. Just we are using. Yeah, it's very clear. Yes. Now you can go for another one. It is going to be sparking of diamond. Yes, yes. Incidented light rays greater than that of critical angle. Now it is very clear. You have been understood that matter. Let's go sparking of diamond. Yes, you can take. Due to total internal reflection, it will happen. Yes, you are going to take that multiple times. Due to the crafting of the diamond, it has been reflected. Again, it has been reflected. So, whenever it enters from air medium to the diamond, what happened? There exists a total internal reflection. Due to the total internal reflection, it is going to be having that blittering, the blittering of diamond. Thank you very much, all of you. Have the nice interaction with well crafted animations. Please do the favor to all your well wishers. So many people are missing these lessons. I hope so, because these are all easy lectures to understand in a better way. Thank you very much.